Hi, welcome to this two-part lecture. So this is the first part of the topic analyzing requirements. So in this part one of analyzing requirements, we are going to be guided by the following business case. So the business case study is going to be the basis upon which we are going to handle the whole lecture and upon which all the explanations will be based. So this is the business case study. It goes like, Fast Food Inn is looking for a way to automate their food ordering process and have decided to hire you. When a customer orders food via the counter, the cashier sends a slip with the order to the kitchen and updates the register with the goods that have been sold and the stocks left after that purchase. The customer is then given a receipt for their purchase. The manager expects to receive reports regularly from the cashier on the operations of the restaurant. You are required to come up with a context level diagram and a level 0 data flow diagram. So basically this business case is giving you a scenario of a business that wants to automate some of these processes. Now, as part of the automation, obviously you're going to have to gather requirements, but after you've gathered the requirements, you now need to analyze them and make sure that the various requirements make sense and that you can come up with a system that captures all the required information and does not lose or distort all the information that it is required. So in this lecture now, we're going to focus on two main methods of analyzing requirements. That is coming up with a context level diagram and coming up with a level 0 data flow diagram. So both are types of data flow diagrams and we'll look at them in depth. So this is the solution to that problem for a context level diagram. Okay, so we'll discuss it as we go, but for now just know that this is the solution and we'll come back to it. Then we also have the solution for the level 0 diagram. We'll also come to it as we go through this lecture. So let's go back to data flow diagrams. What are data flow diagrams? Data flow diagrams are basically ways of modeling a real world situation. So usually it's a graphical tool that will allow the systems analyst to show the flow of data in an information system. So if you look at this, at both these diagrams, the context diagram as well as the level 0 diagram, it has got arrows and some of these funny shapes which we'll also discuss, and these arrows are demonstrating the flow of data between the system and its users basically. So a data flow diagram is basically supposed to show and depict the flow of data within a system. So this helps us to clearly show the communication and the flow of data through a system. So a data flow diagram now makes it easy for relaying of information between analysts, end users, the database designers, programmers, etc. So by just looking at this diagram, the various users of the system can quickly grasp where an issue is, what needs to be tweaked, what needs to be improved, and where the system needs to be done better. So why do we even use a data flow diagram? Firstly, it's easier to understand than text. Definitely diagrams are easier to understand. It's also a way of taking the physical view and converting it into a logical view. So instead of just taking this information which is happening within the restaurant physically, we can actually write it and draw it down on paper and show a logical view of exactly what is going to be happening as we translate the physical situation into a computerized situation. So the physical view is usually the documentation of the system. The logical view is the data that they contain, which we then show through these diagrams. So the main purpose is to communicate with the user and the analyst's understanding of the scope of the required system. So the data flow diagram also helps the user to see how the analyst is understanding the system, as well as for the analyst to be able to convey his or her understanding so that he can get feedback from the user. So let's start with the context level diagram. So a context level diagram has got one process. We'll look at processes later, but just for now that a context level diagram depicts the system as one big box. Okay, so the box that has got a 0 and is written food ordering system is the whole system. So under a context level diagram, you do not break down the system. You just draw the system as one black box. So whatever the processes that are happening in the system, we are not concerned with them. What we are concerned with when we are drawing a context level diagram is how the system communicates with external entities. By external entities, we mean the various users of the system. So these users could be human beings or they could be other systems. So with the context level diagram, we are showing the various interfaces that the system has with other systems or with other people. So in this instance, our case is we want to create a food ordering system. So in this case, if we look at our business case, it says Fast Food Inn is looking for a way to automate systems. When a customer orders food via the counter, the cashier sends a slip with the order of the kitchen, with the order to the kitchen, and updates the register with the goods that have been sold and stocks left after the purchase. So if we are drawing a context level diagram, what we are going to focus on is what external entity, be it another system or a person, is interacting with the system. Who is interacting with the system? So in this case, we are concerned with the customer. The customer is interacting with the system. How does this customer interact with the system? The customer orders food, because remember, I want to replace the cashier. So where the cashier is now the system. So a customer orders food via the counter to the cashier, right? So when it comes to our context level diagram, remember, we're just showing the relationship between the system and its external entities. And the relationship between the customer and the system is the customer orders food, okay? The customer orders food. So the arrow is showing the direction in which the information is flowing from the customer or the external entity to the system, our food ordering system. And then the cashier sends a food order to the kitchen, okay, so that they can prepare the order. And then after that has been done, the customer is then given a receipt for their purchase, right? So here, the system is supposed to produce a receipt which is given to a customer. And then on top of that, the manager expects to receive reports regularly from the cashier on the operations of the restaurant. So that means our system is supposed to produce management reports to the restaurant manager. So the whole point is we want to make sure that on the context level diagram, we are just showing the relationship or the flow of information between our system, which is the food ordering system, and our various external entities. And our external entities are either people, for example, the customer and the chef in the kitchen, as well as the restaurant manager, or it could be another system. For example, maybe at some point we shall link the food ordering system with our ERP system or with our automated delivery system or something like that. And those other systems now, as long as they are going to either give information to the food ordering system or consume information from the food ordering system, they become external entities. So just remember that a context level diagram is showing the relationship between the system and external entities. So as I was saying, the context level diagram has got sources and sinks. So sources and sinks are basically the external entities. A source is basically where the information is coming from. So in this case, an arrow that's going straight, that is going into the system, is showing a source, which is the customer, is the source of data. And then is an arrow that is going out of the system is showing a sink, which is the restaurant manager. So a sink is where the information is going to stay or is going to be used. And then the customer is a source. The same with a kitchen. A kitchen is a sink because it's taking information from the system. So we'll discuss sources and sinks later on in more depth. So as I said before, there are no internal data stores that are shown. So we are not going to add a context level diagram. We are not worried about the internal workings of the system. We are just worried about how the system communicates with other people or other systems. So we only show the external data stores, which are our external entities. So how do you tell the difference between an internal and an external data store? The difference is basically shown by knowing that an external entity is usually a real life object, which could be a human being, another system, an animal. As long as it's a real life object that's not contained within the system, then that is an external data store. But an internal data store is where, after information has been processed by the system, it then stores that information. That becomes an internal data store. So an internal data store only comes into play after the system has processed some information. So let's keep that in mind. So as you can clearly see with our diagram here, there are different shapes that are at play. We've got arrows, we've got rectangles, we've got this oval kind of shape, and we've got arrows and labels on the arrows. So there's need now to explain each one, because these are not just random symbols that are being used, but each symbol is carefully chosen to depict a certain element in this whole communication. So let's look at external entities. So as we said before, I think we've already explained external entities. External entities are represented by a rectangle. So in this case, we have got customer, kitchen, and restaurant being external entities. If we look at our level 0 diagram, customer, kitchen, and restaurant are external entities. This one is a rectangle, but you can see that it's differently shaped from the customer. So this one is a different type of rectangle. We'll explain it and the difference between it and the customer. But if it's just a rectangle that has got no other little shape or anything like that, that's how you represent an external entity. So external entities reside outside the system, but they interact with the system. So they either receive information or they give information to the system, or they also cause the system to produce some new information. So this could be, in our case, our customers and our managers. These are people who are either giving information in the case of the customer or consuming information in the case of the restaurant manager, as well as in the case of the kitchen. So, like I said, the external entity is represented by a rectangle. Now let's move to the next part, the data store. So the data store is another rectangular object within the context level, within the data flow diagram, sorry. So the data store is only found within what? A data flow diagram. Now you can see this shape of a data store. It's a rectangle, but it has got a line in the inside here that's showing some sort of little rectangle again, but at the end here it has no line joining the two long lines. So that's the difference between the external entity symbol and the data store symbol. The data store symbol does not have a line at the end here, but it's got a line in the middle. So what basically does a data store do? So a data store basically represents a database. It represents a file, or it represents any technology that is used to store data. So the simplest way to think of it is to say a data store represents a database where data is either going to be stored, or it's going to be retrieved, or it's going to be updated. So it also basically demonstrates data at rest. It's a place where data is stored before it's used by someone or something else. So another way of thinking of a data store is it should basically represent an entity or an ERD. So a data store is like a table. It's a table in a database. Okay. So if we've got an ERD that has got human beings, HR, just got cars or anything, as long as that thing can be represented as a table within a database, it should be a data store. Okay. So the relationship between a data store on a DFD and an entity on an ERD is that both of them can actually become tables in a what? In a database. So a data store, just remember, represents a database or a data file or somewhere where data is stored. Then we've got data flows. As we said before, for data flows we use arrows. So the arrows show the direction in which data is flowing. So in this case, if we look at our context level diagram, data is flowing from the customer to the system in the form of a customer order. And then data is flowing from the food ordering system to the customer in the form of a receipt. The same goes for the restaurant manager. Data is flowing from the system to the restaurant manager in the form of management reports. So these arrows depict the direction in which data is going to flow. So data flows from an external entity to the system, or from the system to an external entity. So when data flows from the external entity to a system, then the external entity is the source of the data. But when it flows from the external entity to from the system to the external entity, then the external entity becomes a sink because they are consuming the data. So these arrows are always one directional. They are never bidirectional. So you should never draw a bidirectional arrow. If there are two types of data that are flowing from one entity to another, they should be shown by two different arrows. No arrow should have two heads. at O. So let's just remember that. Then we have what are called processes. So processes are represented by this funny oval shape, which I was talking about. So if you come to our diagram, in the context level diagram, we have got that funny shape, which is basically a rectangle at the sides, but it's got an oval shape at the ends. So that shows a process. So what is a process really? What does a process do? So a process shows the transformation of data. So whenever you see this shape or this symbol, it means that something is being done to that data. So this is a process. When data comes into a process, it should be transformed into new data and then released to another process or to another entity. Okay? So it's always an internal process. That's why you'll find that even if you look at the context level diagram, the process is a system. So all processes are done within the system. And then if you look at our level 0 diagram, data flow diagram, you'll find that all these processes are things that are happening within the system. Okay? And they are labeled with what they are doing to the data. So in the case of this level 0 data flow diagram, you'll find that when the customer order comes to the system, the first process that's going to be done is to take that information, to receive it, and then transform that customer data order into a food order. And then the food order is sent into the kitchen. Once you have transformed into a food order, you are also supposed to update the goods sold file. So this arrow is showing that data is flowing from the first process, and this data is the goods sold, and which we update the goods sold file. And this is part of the business case where we say when a customer orders food via the counter, when a customer orders food via the counter, the cashier sends a report. The cashier sends a slip with the order to the kitchen and updates the register with the goods that have been sold and the stocks left after the purchase. So if you look at our level 0 diagram, we are basically moving from when we receive the customer order, we process it, and then we come up with a food order which we send to the kitchen. And then we also need to update the goods sold file. So this arrow is showing the movement of the data of goods sold to the process of update goods sold file. And this process updates that data. And once it has been updated, with this arrow, we are showing that the data is then stored within a data store. Remember, a data store represents more like a database or a storage for the data. So this goods sold file could be a database or just a file. It's updated with the latest information. And then we also need to update our inventory. And then so we take that inventory data, we update it, and then we have an update process that updates the file, and then we store the updated file or information in the inventory file. The same goes for when we are now producing reports for the manager. So the manager is going to take information from a database or from a file, and the information is going to come from the goods sold file, and maybe just to show the daily goods that have been sold and how much they've been sold. And then the inventory file is going to show how much inventory is left, how much is still left in our stock, and then this is going to be used by the produce management reports process, and then we produce the reports and give them to the restaurant manager. So what I want to show is the relationship between the context level diagram and the level 0 diagram. So basically the context level diagram, like we said, is got external entities and the system only. But the level 0 diagram now, it's an expansion of the food ordering system. So it's an expansion of the system that is depicted in the context level diagram. So if you look at our level 0 diagram, all these processes, process 1, process 2, process 3, process 4, they are basically the same thing represented by just one process in the context level diagram. So what does this mean? It means context level diagram shows the relationship between the system and external entities, and then the level 0 diagram shows the various processes that are happening within the system and how they also interact with external entities. So we have basically broken down or expanded the context level diagram when we are coming up with a level 0 diagram. So remember, each process is actually an action that is being taken. So whenever you're drawing a process or producing a process, it should be an action. Okay, basically it's a verb or a doing word or a doing phrase that should be labeled with a process. For example, let's look at these processes here. Receive and transform customer food order. So basically that's an action being taken. We are receiving, that's a verb, right? And we are transforming. So we are actually doing something. Let's look at process number 2, update goods sold file. We are updating something. Process 3, we are updating something. Process 4, we are producing something. So all processes are basically representing an action that's happening within the system. So the data, when it comes from our external entities, so for example, if it comes from a customer, the data is supposed to be received by the system and then maybe produces that food order. So we have taken an action, we have produced a food order, and then we have also now taken that data and subtracted it from our inventory to show that we now have less of beggars in our system. And then we have also taken that information to update our goods sold file so that we show that this is the number of goods that we have sold and this is the amount of money that we have made. And we have now taken that action and then we store that information in our files or in our databases, which are our data stores. And then the manager takes the action of producing, the manager requires reports, so the system produces management reports from the various files and gives those reports to the manager. So just remember that a level 0 diagram is a breakup or it's an expansion of the context level diagram by expanding the food ordering system part. So we are expanding the system part when we are drawing a level 0 diagram and showing the various processes that are happening within the system. So that's basically what a process is about. Okay. So processes do not consume or create data. That's something that's very important to note. Processes just take data that has come from somewhere. The data either comes from an external entity or from another process. Okay, and also a process must have at least one input data and must also have at least one output data. There is no data that is stored in a process because, like we said, a process is basically an action that is just being taken. So if you look at this process 1, there is at least one input, which is the customer order, and then there are at least 2 outputs. So when this customer order is received by the system, a receipt is produced to the customer as well as a food order which is sent to the kitchen. Then there is also the goods sold information and the inventory data. So a process should have at least one input and also must have at least one output. There should also be sufficient inputs to create outputs. So you'll find that you could have even just one input and you have 5 outputs. That's okay as long as the inputs that have been given are sufficient enough to produce that 5 varying data that has been produced. So just make sure that no matter how many inputs you have or how many outputs you have, they should be congruent in that the input is actually the one that has supplied the eventual output from the system or from that process. So what do processes do? Like I said, processes an action that is being taken by a system. Okay, it's not where data is stored. Data does not get stored in a process. It's only merely transformed from one form to another in a process. So a process is just an action or a doing phrase or a doing stage. So in a process you can perform computations, you can make decisions. So here you can determine whether to do one thing or to do another, to move from process A to process B or to move from process A to process C. You can sort, filter, or otherwise summarize data. You can also organize data and you can trigger other processes. So if you look at our diagram, we are moving from one process to another. So after doing this process, you will trigger process 2 and process 3, which will also store information, and then process 4 is triggered by taking information from that from those data stores. So you can also trigger other processes. Then you can also use stored data, like in the case of our manager here. A process is using stored data. The process number 4, produce management reports, is taking data from the goods sold file and the inventory file and using that to produce reports, which are then given to the restaurant manager. So in summary, we have said the rectangle is showing that this is an external entity which is outside of the system but interacting with the system. Then the data stores are represented by a triangle that has got no line at the end, at the right end, but it's got also another line inside it. So you'll find that the D1 part here is demarcated by a line that is inside. So these files are representing our data stores. Then we've got this shape, the oval shape, which is representing a process, and a process is what's being done in the system. So if you're going to tell a story using a level 0 diagram, we would say the customer orders food. The system receives and transforms that customer order and produces a food order which is sent to the kitchen. And then at the same time, the system will produce information on the goods that have been sold, and will go and update the goods sold file. And once the goods sold file has been updated, it is saved and stored with either in a file, in a database, or whatever data storing technology you're using. The same goes for after the information has been transferred, this food order information has been produced. The inventory data for the restaurant is also updated using the update inventory file process. And then the inventory file is updated, and the two are then used to produce management reports by supplying, if it's the goods sold file, it's supplying the daily goods sold amounts, and if it's the inventory file, it's supplying the daily inventory depletion amounts, and these produce management reports which are sent to the restaurant manager. So we should just keep in mind that that's how the interpretation of this business case is done using these diagrams. So this diagram is trying to break this business case and put it in a diagram format. So the first way is just using a context level diagram, just to show how the system, which is the food ordering system process 0 here, is interacting with other people or other system. So in this case, it's interacting with the customer, with the kitchen, as well as the restaurant manager. And this is based on the story that we have heard here. Then after we've come up with the context level diagram, we now need to expand this food ordering system to see exactly what's happening in the system, how data is moving in the system. And that's where we come up with our level 0 diagram. And in this level 0 diagram now, we are now trying to take care of the issues that have been discussed in this business case that are not involving any external entities. So issues to do with updates the register with the goods and they have been sold and the stocks left after that purchase. Updating the goods sold file as well as the inventory has nothing to do with any external entities. That's an internal process system. So a system process. So it's done within the system. So now we need to show that within a level 0 diagram. But another thing to note is that when we are drawing our level 0 diagram, we still maintain the integrity of the context level diagram, because all we are doing is we are expanding this, but these arrows that we have drawn in the context level diagram should also appear in our level 0 diagram. So as you can see, the customer order is here, it's also here. The receipt is here, it's also here. The food order is here, it's also here. Okay, and the reports are also there. So what you're basically doing is you're not losing any data that you have produced in the context level diagram, but you're just merely expanding the system part of the context level diagram to produce the level 0 diagram. Every other information should also be retained within that level 0 diagram. So we've discussed about the types of data flow diagrams that we want to produce. And we can produce the context level diagram, which we have spoken of, as well as the level 0 diagram. So there are different types of data flow diagrams that we can have, but these are the only two that we're going to focus on for now. You can actually break this data flow diagram further into level 1, where you even break each process further into 2 or more processes. But we are not really concerned with that level of complexity at this moment. So we'll leave it at that. So how do you come up with a data flow diagram? So the key thing is to first read and understand this. Read and understand the business case that you have been given. That's the first thing that you need to do. Read and understand the business case that you have been given. Okay? And then secondly, the way I would approach it is as follows. I would say, number 1, identify external entities. So as you read your business case, the first thing that you're supposed to do is to identify all your external entities. So when you have identified your external entities, in this case in our business story we have got customer, it's it's an external entity. We have got kitchen. There is no kitchen in the system, so it's an external entity. And then there is a restaurant manager. There is no restaurant manager in the system. It does not stay in the system, so it's an external entity. Then the second thing that you are supposed to identify are your processes. Okay, so your processes are basically the actions or the doing words that are being said in the system, in the story. So these will now become your processes, which will show in your either in your processes, or it shows the information flow. So these are processes and arrows. I would just say arrows showing the information flow. Okay, so that's what you're now trying to involve to identify, and these are shown by the actions or doing words that are in the statement. So in this case, our processes will be, or the actions being taken, a customer orders food, right? So customer orders food is actually an action being taken. So it could either be a process or an arrow. Customer orders food. And then another one would be customer orders food. The cashier sends a slip with the order to the kitchen. So cashier sends slip to kitchen. Okay. Cashier to kitchen. That's another action. And then after cashier sends slip to kitchen, the cashier updates the register with the goods that have been sold and the stocks left after the purchase. So here, and other actions that are being taken is update a goods sold register, and also update goods left register. And then you come here again, you identify the next actions. The customer is then given a receipt for their actions, for their purchase. So give customer receipt. Okay. And then the manager expects to receive reports from the cashier or from the system. And here, so it means what? Give manager reports. Now, what we have now done is we've identified our external entities. We have identified our processes and arrows, basically showing our information flow. And now we also need to identify our data stores. Okay, what data? Now, data stores usually within this information are not clearly defined, but it's up to you now to realize that, okay, if we are going to update goods sold, what doesn't it mean that there is somewhere that we are storing this information? If you are going to give the manager reports, it doesn't mean that there is somewhere that we are actually retrieving this information. So you are storing or retrieving information from a database or from a file or from whatever storage you have. So now you can see that you need some data stores to store some information, and the information in this particular case that you need to store is the goods sold, right? So you store it in a goods sold register, and you also need to have the goods left register, which is called the inventory. So you create an inventory register or file or table, whatever it is, and then information for the reports is taken from these data stores. So now you have identified these three very important parts: the external entities, your processes, and your data stores. Now you can come to your data flow diagram and say, how do my external entities interact with the system? That's why you now start joining them using these arrows to say, from the customer, the system is getting customer order, and then from the system, the customer is getting a receipt. From the system, we are getting a food order, which is going to the kitchen, and from the system, we are also getting a restaurant manager. Then when we want to break down and show all the processes within this system, remember also these processes are done in the order in which the information is going to flow within the system. It's not just a haphazard way of showing, but the arrow flow is showing the information flow from the first process right up until it's either stored in a file or data store, or until the information is retrieved to do something else. So these processes are not organized haphazard. So now you take your processes and then you start creating the arrows in the various processes that process this information within this data flow diagram, as well as putting your data stores. So in a nutshell, that's how you actually need to do a data flow diagram. You need to identify your external entities, your processes and arrows, as well as the data stores. And then you need to do this process iteratively. So you find that data flow diagrams are basically a design process. Okay, it's not something that is just done once and it's done and you get it right. No, it's more like you're designing a system. So your first data flow diagram may not be perfect. So it needs to be done iteratively, and you need to apply gradual refinement. So with each data flow diagram, you are perfecting the diagram, you are perfecting the arrows, you are creating the various processes. You are either adding more or removing other processes until you come up with a concise data flow diagram that shows you exactly how the system is going to work. So these are other ways of doing it, but the one I've explained to you is basically the simplest way of coming up with your data flow diagram, and then you iterate using those things until you come up with a diagram that connects the external entities as well as the various processes and arrows until you have something that's very concise. So there are some rules that you need to follow as you draw these data flow diagrams. Okay, you need to follow certain rules, and I think we've already mentioned some of them, but let's just go through some of them again. The first one, as we said, when you're drawing a process should have at least one input and at least one output. Then a data store is only updated by a process. So a data store is only connected to a process. What's the problem of connecting a data store to an external entity? Remember, a data store is a database, and an external entity is something outside the database. So if we allow an external entity like our customer to directly update our goods sold file, then how do we know that information is actually correct? How do we know that they do not end up stealing the information or corrupting our database? So always remember that a data store is only connected to a process. It's never directly connected to an external entity. Also, an external entity is connected to a process. So if you look at our diagram, an external entity is connected to a process. Okay, even on the context level diagram, the system is represented like a process. So the external entity, customer, restaurant, kitchen are connected to a process. Okay, that's also a data store is connected to a process, and an external entity is also connected to a process. And then, as we said before, the flow of data is shown by an arrow with just one head. Okay, so data flows only in one direction. No arrow or data flow is bidirectional or shows two arrows. If you want information to flow, if you want information to flow between two entities, whether it's an external entity in the system, you don't depict it using one arrow, but you use two or more different arrows. For example, in this case, as you can see, the customer is ordering to the system and the system is giving the customer a receipt. We could have just represented this with just one arrow, but that is wrong because it's not really showing us what exactly is the system giving to the customer, what exactly is the customer giving to the system. But when you do it this way, where we split the arrows and clearly show the direction in which information is flowing, we can clearly know what is giving what and who is giving which. Then these are some of the mistakes that people make as they draw their data flow diagrams. So if a process has no data flowing in, remember we said the process should have at least one input and at least one output, but for some reason in this case there is no arrow showing the inputs, but there are arrows showing outputs. So this is a mistake. Then here we've got a data store that is connected directly to an external entity. Remember we said that's also wrong because it can cause to a lot of problems. Then we have got bidirectional arrows between our processes. And we said this is wrong because it does not show us the true nature of how data is flowing from one process to another. So we have spoken of this and what a sink and a source is. So we said the source is where data is coming from, and a sink is basically the person or the other person, a person that is, or an external entity that is using the information produced by the system. So when you're drawing your system now, there could be there could be cases where you've got 2 or more arrows coming in or going out of the system. So there could be an instance where probably we could say the goods sold information is going to 2 different processes. Now you can represent that if the goods sold information is going to 2 different processes, you can represent that using an arrow that has got forks. So it's 1 arrow coming out of the receive and transform customer food order, but it then splits into 2 because the same information is being used by 2 or more different processes. But in this case where the goods sold and the inventory data are different, they should be represented by different arrows. So a data flow cannot go directly back to the same process it leaves. So if information is been produced by this process and it's coming to this process, you do not draw an arrow directly from update goods sold file and back to receive. No, you draw an arrow that goes through another process where you state what's happening in this process, and then it goes back to the receive and transform customer food order. It does not go where goods sold is given to process 2 and then process 2 just gives information directly to process 1. That's not how it goes. It has to go cyclical through another process back to the original process. Then a data flow to a data store means we are updating data. A data flow from a data store, it means we are retrieving data. So if an arrow is going towards a data store, we are updating data and storing it there. If it's coming from a data store, we are actually retrieving information of the data store. So like we said, you should make sure that there is always an output for every input and an input for every output. That's basically what balancing DFDs is all about. You just have to make sure that for every input that's coming, there's an output going out from there, either to a data store or to an external entity. So basically that's what data flow diagrams are. So in this first lecture on analyzing requirements, we just covered data flow diagrams, and we based our whole lecture on a case study where we were looking at a fast food inn which wanted to automate some of its processes, and we looked at how to produce the context level diagram as well as the level 0 diagram. So thank you very much for listening to this lecture.